So I had a really tough time understanding this week's material, so we'll see if I do okay on this. So for step one, you just go ahead and pull a random sample, which I did. To look at the sample, we see that 16% do care for offspring, which I marked that over here, just so you could see where the ones that do care for offspring land. And then the average for weight was 13.46 pounds with a standard deviation of 3.42, which just means that most of the galutes in this sample fall within one standard deviation, so between 10 to 17, which we can obviously see looking at the graph. But all of them fall within 3 standard deviations. And then the smallest galoot that I had was 6 pounds, which you can see right here. And then the largest is 21 pounds, which is right here. So then for the confidence intervals, what ended up happening was we had a lower limit for the proportion who care for offspring, which the average for this was 0.16 or 16%. And the lower limit was 0.3, and then the upper limit was 0.29. And then I don't know, I thought representing it this way made it a little bit easier to tell what we were looking at. And for weight, the lower limit was down here at 12.2, while the upper limit was at 14.8, and then mu, or the average, was at, let me see where that went, was at 13.46. So all that means is that we are 99% confident that the proportion of those who care for offspring will fall between 0.3 or 0.03 and 0.3 or 0.29. And then same for weight, that we are 99% confident that they will fall between 12.2 and 14.8. So then over here, we wanted to walk through the 5-step hypothesis for each variable. So for the proportion who care for offspring, the null hypothesis is that p equals 0.20. And then the alternative hypothesis that I suggested was that p was greater than 0.20. So you go through and you make sure that it's random, that this is something that fits. Just trying to think of my wording. But it's a random variable that has 10%. And then you go ahead and calculate the different, like the z-test statistic for this one and t-test for this one. And p-value for this ends up being 0.4404, which I represented over here. These are my nice shadings in on the graph. Oh, and I forgot to say, I did make sure that it's obviously relatively normal distribution. Okay, so then because the p-value is what it is, I cannot reject the null hypothesis. So it remains true that the proportion of galoots that care for offspring is roughly 20%. And then same for weight, you go through all the same steps, so making sure that this fits that. So it's a random, independent sample, has the 10%, and it shows in the histogram that we looked at before, which is apparently not going to load, that it was relatively normal. So we do our calculations, and then we get a p-value of 0.3478, which I represented, again, both sides on this graph and did some lovely shading in. My hypothesis, the null hypothesis, was that the average weight for galoots is 13 pounds, and then the alternative is that it doesn't equal 13 pounds. And again, we cannot reject the null hypothesis, so it stands true that the average for a galoot is 13 pounds. And then the relationship between the confidence interval and hypothesis results are that we use the data to create the confidence intervals that we use for the hypothesis test. I'm recording for a class right now, so you need to get out.
he was in here.
Sorry. I don't remember what I was saying. But the data that we used for the 99% confidence interval, the data that got us this, and because the hypothesis remained true, there's a relationship between the two. I think someone else is going to have to explain that a little bit better. Maybe I'll have to go back and rewatch the videos. But and how do I think my results will compare to other people's results? I mean, the means and this stuff will obviously be different, and the confidence intervals may even be slightly different. But I think the inability to reject the null hypothesis will remain the same, just because I believe that the null hypothesis is true. So that's all I have.